So I thought we'd take a look at this Simpson multimeter. I picked this up at that same yard sale, yard giveaway I mentioned previously. It's a pretty compact little unit given the era. I'm not sure when it was manufactured. Haven't really found anything that gives me a date, an idea of the manufacturing date. In this pouch in the back are the leads. I know that the positive lead has an issue, just based on an early test of the leads. This lead appears to be broke right inside of here, very close. This has got the backwards probes where the female is on the end of the probe and the male is down inside, so I just can't plug a regular set of probes into it. Luckily it came with 2 ground probes, one a regular probe and one an alligator clip, which will help in mucking around with it. The tip of the positive probe, I don't know if you can see that, has been, it looks to me like it was probably melted off. Something bad happened to this probe. Apparently you can buy probes through, I think, Probe Master that'll work with this. Go ahead and put some probes in it. Power it up. It doesn't have a backlight, which may well mean that it'll be impossible for you to read the screen. I guess we'll find out. I am on the ohms range, the 200 ohm range, and we get 0.4 ohms, which through the leads, 0.3 is probably pretty reasonable. At 2k ohms, you know, it's zeroed out. I took a bit of a poke at this earlier, and functionally it seems to work. I haven't looked at anything like calibration. It had an issue up front with these switches not engaging. That seems to have cleared up with just playing with them a bit. Battery compartments here on the back. I did have to put a fresh battery in it. It's an interesting battery cover. It's just a standard 9 volt cell. It's the replacement HRC fuse. I was actually surprised when I put the battery in to see that it had HRC fuses. Let's see if I can't get the battery unclipped. So there's a spare HRC fuse here, a BLS3. It's a little fuse. Based on the age of this, I'm pretty sure it's legitimate, not like a cheap Chinese knockoff. I'm assuming to open it, these 2 posts unscrew. That's just based on looking at the design. Oh, that worked well. Almost lost the washer. And that one, I can see the post down inside of there rotating. So it looks to me like maybe the mounts broke. As I see no other screws, I'm assuming this is enough. Yep. Correct, it was enough to remove it. It's got some thin printed circuit board on here, obviously is shielding. The foam, it looks like that was inside of it has disintegrated. Yeah, this post here That needs to be, looks like epoxied back on. Yeah, it looks like that was glued on at a later date. I'll have to epoxy that post back. There are brass inserts in these, so at least they did that well. Five potentiometers. We can see a couple of chips in here that have got hot snot, it looks like, holding them in. It is a jungle of wires inside of there. How does this come apart? Does it come? Ah, I see. I don't know if you can see this. I can't find anything to point with. There's some pin headers here that look like they hold some part of it together. Well, let's pry on the pin headers and see what happens. That's a little tight. It did start to move. I don't see any solder through this back board that makes it look like it's soldered on. Or do I have underneath the shield? It's hard to say. I don't see any screws anyplace. Now, I don't want to break it, but I would like to take a peek inside. A couple of rivets. This backboard is floating. It really looks to me like that backboard just floats in there. Oh, maybe there's some solder bridging the two boards. Yeah, I think there is. Well, let's gently pry a bit on the pin header. Very fine little screwdriver that'll fit in there. It's a little bit too big still. Have I got a really small one here? I'm hoping the audio in this is a little better than it has been in the past. I've added a bit of attenuation on the microphone input. There, it released. Okay. Okay. That made a difference. Boy, are those two rows of pin headers, that cannot just be for the LCD. I may have to pull off the shields here. Oh, I see a pin header in there. Now that I look deep enough. There we go. Boy, is this a jumble of wires inside. Well, it's, oh, there's a broken lead. That's just friggin' wonderful. Was it broken before, or did I break it? Definitely not built to be serviced. Yeah, both boards are through-hole construction. I'm not sure how good a view you're getting of the interior here. They're pretty standard gang switches from the era. Same thing up here. Some of them are ganged. First three are ganged. Of course, that's the power switch there. Wish I knew where that red lead came from. Well, the black one's not in much better shape. Get a close up here if I can of that black lead on camera. So that when I break it off accidentally here, I've got a chance of reattaching it. Slightly better pair of glasses here so I can see a little better. Yes, I live in the world of reading glasses. That's most likely where that red lead came off. Right there. A little bit clumsy to hold on to. There's some interesting construction in here. I don't know if you can see this. Here's my little pointer. Don't know where the little pointer is, but I will point with this guy. In here, there's this orange capacitor here, and there's a 3057 transistor here that is soldered into the switch and over to the pink wire here in the switch. It's interesting that that transistor is directly in the switch. And that switch is the... See, those are the range switches. That switch is the peak hold switch. That's interesting. So that's an interesting bit of construction there. There's this little daughter board here that looks like it has diodes on it. That's again interesting. Well, I think I'm going to attempt to peel some of the shielding off. Let me get a soldering pencil tip here that'll work for this. It's my JBC soldering station. Really high quality tool. Really like it. It's made working on stuff far easier, and the speed that it comes up to temp is just incredible. I've just pulled it from the cradle. Oh, it actually pulled the pins from that circuit board. Now, it'll be a little bit tricky to put back together because of that, but yeah, it pulled that pin. As well, the pins have stayed with the shielding copper in both instances. The pins stayed. with the shield. So that's just nothing more than a stiff piece of wire. No surprise. The solder looks okay. Everybody's still nice and shiny. Interesting that there's a piece of wire bridging across those 4 pins. All 4 of them are bridged. I don't see any other kludges. There's your little resistor sitting here. Yeah, this backboard is using solder bridges to connect the 2 boards together. There's a large pour there, a larger one there, and a larger one there to probably give it mechanical strength, and there, and then there's just individual. Well, it should probably be retouched up. I put it back together just to make sure I haven't cracked any of them. Let's take a look at the couple of chips in it. Help if I could get this other display off here. I don't really have anything to leverage, and I don't want to break the liquid crystal. Boy, that little pin header is really in there tight. No surprise, it's probably been in there since the day it was manufactured. There it comes. So, text upright with the unit upright. Issue 4, potentially 42nd week of 86. There's a 4286 sitting in there. That would be reasonable, I think. It's a double-sided board, but the soldering is horrendous. Most of it is not flowed through out of the pins on this side. I guess we're laying on the plate through. Some nylon isolation posts. Unsoldering those is going to be painful. Buzzer back here, I assume, for the continuity test. So this has got to be the display chip. It's 23rd week of 86. So yeah, we're in the 1986 time frame. It's a TSC7106 CPL201. I'm assuming that's a display driver, and that would most likely make this guy the chipset for the meter. I don't recognize the symbol offhand. MD4332BE, 29th week of 86, and B01050B6. What else have we got in here? 1407, 1409, 1405. So we've got some Jelly Bean CMOS logic. NMC74C 221, Jelly Bean TTL. One of these two may be the voltage reference. TL062 CP, I don't know. It's interesting. Again, I don't know how good a view you can get here. pin one on this guy's here and pin one on this guy's opposite corner. They are flipped 180 degrees from each other. Sure, that made the printed circuit board layout potentially easier. That's an ICL7621. I'm guessing that is probably the voltage reference. And that's probably an instrument amplifier. It'd be my guess. Boy, it's just a sea of wires. And the places they're going to really aren't labeled. Which is, I mean, the black and red here are labeled. But these others, the gray, the yellow, aren't. Based on the little bit of wire poking up through that via, I'm guessing that's where this broke free from. Again, that little daughter card with the 4 diodes on it. It has 2 connections down to the board. There's 4 diodes on there. That's in line with the AC-DC switch. Oh, interesting. So that must be how they are rectifying AC to DC. To measure here's on that little daughter board. I wonder what they originally used in there. So I'd like to say this blue capacitor is mounted for stress relief, but it's just the easiest way to get it onto the board. Just mount it upside down, flip the leads over. A couple of electrolytic capacitors. There's a can over here. 838JH, 40th week of 86. That's on the display side. Again, don't know what it is. There's a couple of ICL7611, a couple of them here underneath. The volt ohm input. I'm going to break more wires off. Is this terminal crossed here with a big power resistor that drops straight down to the board. Yep, drops straight down through. And then there's a piece of wire that runs off it. There's a capacitor it runs through. So they must be doing some DC blocking. It's interesting, it goes straight into... So that's the volt ohm input, and it goes straight to that power resistor. Can't read the value on it. Diode bridge tucked in there, and of course, eventually we get to the thin film resistor network here. High meg. It looks like it's sealed. I just see ceramic on both sides. Little adjustment item, and I'm not really familiar with the package. It looks like a coil slug to me, but I'm not sure. I've seen that in a couple other instruments, never looked up what they were. Oh, that's interesting as well. So that switch is the slope switch for the peak hold, and it's got 2 transistors hung directly on the switch. Looks like to me they're configured as diodes. 2 pins soldered here, 1 here, 2 pins soldered here. So that's interesting. Well, there's a quick look inside. I will do a repair to reattach that missing lead. Boy, the construction on this is willy-nilly. You probably won't be able to get it on camera, but maybe you will. Behind the pots in here is a little, it's got to be like a 16th watt resistor, just kind of tacked in diagonally across there. Definitely add it on later on. The place where this can is actually a dip outline back here. Would have been an 8-pin dip. Now more than that. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5. Some kind of a dip outline anyhow. And they've used this can and just bent the leads to various places to get it to fit in there. So that's interesting. Of course, just some transistors floating around. Is this a test point of some kind? There's actually a pin that lines up to that. Oh, no, that's the stud where the shielding came down through. The shielding didn't need to be unsoldered to be removed. It was just pressure fit in some pins, so that's my bad for not trying to just slide it up out. I assumed it was a direct solder connection. Live and learn. I'll remember that next time. I just break another wire off. Yes, I did. I have to spend some time putting... Oh, no, it is actually... Oh, sweet. I wish I'd have noticed that originally. Those are actually... These leads are actually socketed onto the pins here, the red and black. That does make things easier. I just assumed they were soldered connections. Yeah, it'll make it a lot easier to reattach the red wire. So hopefully that's a little better view of that card. 3 trimmers. Just no idea what they trim. I don't know if there's a calibration. 2 more on the back here. Don't know if there's a calibration manual or process available. There's the 2 wires that go to those pin headers, the power resistor. That's actually a mauve now that I look to there. Not a, yeah, that's not a capacitor. Like I thought for DC blocking, that's actually a, well, shoot, I say it's a mauve. Maybe it's a mauve, maybe it's a cap. It's hard to say. Where it comes through doesn't appear to be going to a ground plane. A little tuning. I'm sure somebody will be able to tell me what this is. I've seen them before. Sure I could figure it out. Definitely more hot snot to hold the ICs in place. Now, I'm going to set this aside for now. I've got some errands to go run. And we'll come back and repair the broken wire, put it back together, and see what we've got. Now let's take a bit of a peek at seeing if we can reattach this little bit of wire. Trying to just score the insulation enough without cutting into the wire itself. It's a multi-core wire, but it is, I mean, it's stranded. But it's very stiff. Get just enough here. There we go. So that's already tinned pretty nicely. There are 3 holes there. Yeah, I can see the bottom of the wire coming through there. Make sure my little vacuum pump here will do its job. Try not to have my hands in the way of the video. though no matter what angle I get at, I'm going to be in the way. This guy up, it's flowed. I think that got the hole opened. Here's the piece of wire we removed. You know what, the black one's failing as well. Might as well do both sides while I'm here. You know, I don't think I'm ever going to use this meter for anything, but yeah, the black one's every bit as broken. But I'm still going to clean up the hole and remount it. Probably going to have to come at it from this side. It's a rather tight little bill down in there. Hopefully I've got this somewhat in frame. It's going to be a bear. It doesn't want to release that little bit of wire. I have to attempt to push it out. Not quite. Boy, that guy's being a real bear. Let me change tips here. This is a very fine point tip. It's actually bent. I wonder when I bend it, I might be able to push it on through. If I can get the wire to drop out, then it'll be easy to evacuate the hole. Yeah, I think that, yeah, there it is right there. That got it. You can't see this, but I am hot swapping the tips here. Which works really well on the JVC. Really like how easy it is to hot swap tips. The holes look reasonably well opened. Will the red one fit through? Fits through nicely. Let's do the same. Work on the black one as soon as I spot wherever the exactor rolled off to. Just lightly score the insulation here. Idea is to not cut all the way through to the wire. That looks good. And there we go. That black piece may not fit through the hole. through just fine. Sorry about the interruption. I received a phone call. I don't know if you can see the two wires here jiggling. I've got the cleaned up wires through the board. I'm going to go ahead and solder those up. And that should effect a repair for that broken wire. And for the other wire that was very loose. Put on the good glasses so I can see better. I think generally those solder joints are okay. There are the two right there. I'm going to go ahead and trim off just a little bit of the lead that's hanging out just to shorten those up. We've got the switch reattached. Straighten out these pins without breaking them, hopefully. I don't think there's anything else on this board that requires immediate attention. I believe I can restack this. The text went up on the LCD. That's reseated. This is going to be a bit tricky. See, the red is to the front. Black is to the back. It's shady in there. Of course, the glasses I'm wearing have a pretty fixed depth of field. There we go. This comes around to the front. Those line up there. I don't have that square on the back. Okay, I have square on the back. So the sandwich has been put back together. I'm inspecting all the solder joints along here. I'd said I may retouch some of these up. And I think I'm going to go ahead and do that. Just because they're just simply using solder to tie the two boards together. Now, again, apologies for the hands being in the way. I may have to figure out a different camera angle. That turned ugly. There's 2 more signals down here that actually look like they're probably fine, but I will reflow them. This board, I believe, set on that way. Yeah, that's correct. Power switch is off. Don't have any plastic laying around down there. Now let's see if it'll power back up or if I've completely killed it at this point. So we've powered back up. Settle down on volts. See, it's volts, milliamps, ohms. Open. AC, DC, and peak hold. Well, looks like there's some progress there. It's just a normal smell, not something getting hot. So that's kind of interesting. Don't know if there's a way to manipulate those leads back a little bit. To kind of hold that place a little bit better. Well, we slide it back into its little case. But it's a tight fit. There are a set of card guides. That is rather tricky. It keeps wanting to fall off. So is it right on top of those little card guides? It looks like it does. Or is it meant to ride below them? So close. There we go. It's interesting to have that whole board there on the front with the red and black leads off of it. I had to repair just for this little switch, especially as heavy as the wire was. Of course, I didn't put this post back in place before I slid it in, because you know doing it twice makes it better. Screwdriver's too small, the other was a little too big, but such is life. I was afraid of that. That floating PCB has shifted. Yep, it has certainly shifted. Now, is it centered enough? These still engage? It is. Everybody seems to move okay. Put in the other screw with the other post. If I can get it to catch down in the threads. Snug it up. Certainly looks to me like it's in wrong. Maybe it is. No, the back seems to line up okay, so I guess it's not. It's just a sloppy fit in there. Yeah, it's fine. Volts. Took quite a while to settle down. Milliamps, ohms, off to infinity. That's interesting behavior. Let's take the middle scale here. Yeah. It's at 200 millivolts down on this scale, which is why I think it takes a while to settle down. So that all looks okay. Put the spare fuse back into the little holder for it. Line back up the little backside here. Well, it's got a QC stamp here on the back. 25th week of 87. Backlight would of course have been nice. I got no idea if that LCD shows up. The screen, it does a little bit. Doesn't show up great. Well, there's at least the meter back together, the broken wire reattached. I wanted to move on. I've taken this lead, and if I put pressure right here where it comes in, I can get it to make contact. So I know the break is in that general area. I'm going to see if there's a way for me to open that up enough that I can maybe effect some kind of repair. Whatever I do obviously won't be pretty. course, it all depends on me finding the X-Acto. There it is. And I think I'm just going to roll around this little molded strain leaf here and see if I can cut through it without cutting in so deep. I take the wire out and hope that a little piece of the wire is available in there someplace for kind of a... Okay, it's starting to float loose. It looks like it is molded onto. That's cut all the way through on that side. Not quite on this side. Probably pretty unexciting watching my hands here. See if I can slice this down the middle and peel it away from the wire. This side's going to be a little bit harder. There we go. Yes, I know, I'm cutting towards myself. A fool and his finger are soon parted. Hopefully I can end up with enough wire to solder onto to at least make the probe usable. Yes, not the most elegant of design or of repair methods. through to the wire. Through to the wire. And there we go. Yeah, it's definitely broke. In there. It's amazing how the one tool you need is never where you can see it even though it's laying out in plain sight. So you can see the depth up to the break here. So it was broke right in there about where I thought it was. This will be an interesting repair. Rubber insulation is not always the easiest to cut. There we go. I guess I'm just going to just do a butt joint there. Won't be a butt joint overlap. Strain relief, getting strain relief on that's going to be difficult. I'll be able to bring some shrink tube up into there. This will help, but it really won't provide strain relief. Well, let me go find my shrink tubing. Okay, we have some shrink tubing. The question now becomes, what can I do with it? Can I get that to grip on there well enough to provide some kind of strain relief? I think I probably can. Dig here for bits and pieces of pre-cut. Try to build this up. I'll be that way. Don't have a lot of red shrink tubing left, it looks like. Popular color, not that it really matters. Deep inside here, it'll be covered up by that big piece of black. It's going to ultimately provide some strain relief. That's a little too tight. That's the same diameter. Looks like it's the same diameter as well. So I think I can make it work. A little cat rating sticker, if it'll peel off. Since this kind of repair, this probe's no longer going to be safety rated. That's just going to be too tight. Anything with a slightly larger diameter? No, that's even smaller. same, slightly smaller. I'll actually slid on there a little easier. Just take a piece of it. Slide it onto here a ways down. Hopefully without breaking more wire. I want a smaller piece of this to go directly onto the solder joint after I get these soldered. Because I should go ahead and tin these up. Looks like decent lead wire. Let me trim the little piece of strain relief cord out of there if I can. I really can't. Little piece of nylon or cotton, some kind of thread. Now let's see if I can get that little bit of lead to take some solder. Hopefully it'll wet without adding a lot of flux. Yeah, that's wetted just fine. No matter how much stuff you have, there's always something in the way. So we want to wet this. Oh, that's nice and dirty. There it goes. Trim a little sharp point off of that. Now the interesting part will be holding those in sufficient alignment that I can get the solder to flow. Come up with a way to do this. It's pretty close. Hopefully this is making it on camera. Slightly is. I don't use these little helping hands very often, but it's actually holding the two of those together. Pretty nice. But you know what? Before I solder, I need to put the rest of the shrink tubing on. There's going to be this small piece that's going to go directly over the joint. At least that is the plan. And a bigger piece that'll come in. One of these will get shrunk. Kind of thinking about the order to bring these up, since it's going to have a fair amount of shrink tubing on it. Larger one. One of these will get shrunk, and then one of these will get shrunk over it. And the piece that I kind of want to work up onto the handle if I can, or the make it about that size. We'll see how this turns out. Done that before. Got everything hooked together and then realized I didn't have the shrink tubing. in place, which is always kind of tragic because then you got to unsolder. Try to get a good flow on both sides. Let that cool for a bit before I stress the joint. Well, I think mechanically we've got a good joint. Need to continue to let that cool down. This first little piece hopefully will slide up. And directly over. Oh, come on. I knew you were tight. Don't be that tight. I want you to slide up onto there. Well, it's time to break the heat gun out and see what we end up with. Picked this old guy up at Radio Shack, the one that was going out of business for, I want to say 90% off. Definitely going to make some noise here. Apologies. That shrunk down fairly well. Maybe hit it a little bit more. The idea was for this piece to slide up over that piece, hopefully. Like that. So I got the short inner piece shrunk. I've got a little bit longer over the top of it here. Rearrange these a bit. That is making some hot air. Let that cool a bit. I don't know if I'm going to be able to reuse the little. I'd like to get this back on just so it'll help build it up so the final piece of shrink tubing has something to bite over. I think that'll help with rocking. We'll find out. Again, ultimately, it's just the solder joint that's holding that together. And I don't know how well this will shrink on there. It's certainly not going to shrink down as tight as I'd like inside of there. It's getting pretty close. So there's what I've ended up with. It's not great. It's a little sloppier here than I would have liked. One more piece of shrink tubing would have been good. But it's a little late. I'm not getting anything small enough diameter on there. But it does do a good job to keep it from flexing. You know, up in where the solder joint is. It's just mechanically you don't want to pull on it. But, you know, compared to what I had before, a broken lead. Set this aside so I don't burn myself. Let's see if we actually have a lead that works. This lead for the common on. We're on the 200 ohm range. It broke someplace else. Oh no, it's zeroing. Well, I'm on volts, that's why it's not acting the way I think it should. There we go, there's an open. Yeah, we have a working set of leads. Say the red one with the blown off tip isn't great. But you know, for what it is, it's not half bad. So now to play a bit with it. See what we can make it do. Let me figure out a way to get some stuff wired up here. Well, I'll look for some things to measure. So I've got a couple of current shunt resistors that I put together for a different project. This one is 0.100 ohm. It came out pretty close. And this one is what did it measure? 1.0005 ohms. So very close to 1. So on the 200 ohm range, the nominal lead resistance is, well, it did 0, which is nice. So let's see what it does with the 1/10 of an ohm here. I may not be getting good. Well, that's interesting. Oh, there it is. So 0.01 with the meter does 0. I don't know if you can see that. The meter does 0 if I get good contact. If I get in on this 0.1 ohm resistor, I get 0.1. So, like I say, this resistor in the end, this little pack measured out at 0.100 ohms. So, this should be 1 ohm. Let's see what we get here. 1.0 ohm. I'm happy with that. For what this is, that's actually pretty accurate. And this is around 47 ohms. It's really meant to be a cheap 50 ohm dummy load. Again, for a project from way back when. And 47.4 ohms, that's well within what the spec ended up being for this. I don't remember exactly what it actually ended up being. We can find out. A second here to fire the Digital meter up. Oops. Go to ohms, 4-wire. That's nulled out to 3 decimal places. And it's measuring 47.249 ohms. And on here we're measuring 47.4. So, that's acceptable. So at least on the low ohm scale, it seems reasonable. Get these sorted back into their little baggies. So we know the low ohm scale works. I think the next step is to feed some voltages to it, see what we get. So I'll do that next. So I'm hooked up to my Digital DP811 lab power supply, which is outputting 0 volts at the moment. And if I actually bring the leads together, it null's pretty close. Let's see, DC is out. So I will bring the voltage up a bit here. So that's 0 out. I just brought it up 10 millivolts, 20 millivolts. So we're on the 200 millivolt range. Oh, that's actually pretty close. So that's showing 1.3 millivolts. So this would actually be 10 millivolts. Shows 11. Looks to be about 1.5 millivolts error, which could probably be calibrated out. Let me come up to 100 millivolts. There's 100 millivolts. Should be overranged. Sorry, got a dog coughing in the background. Let's go to the 2 volt range, 192 millivolts. So we're seeing about that same error, a few millivolts. We'll come up to 350 millivolts. $750 millivolts. You okay, little girl, back there? Yeah, she's an elderly dog. You probably heard her kind of choking a bit in the background there. She's fine. So there is 1 volt. Let's take it up to 1.5. 1.5 volts. You know, it's close enough. Get it right at 2. So there, I'm showing 1.990. So of course at 2 it'll overrange. The 20 volt scale. Actually, we want larger jumps now. Come up to 5 volts. 5 volts. Keep overshooting and then undershooting. 10 volts. You know, it looks like the little meter is pretty accurate. Let me go to range 2. And we'll come up to the 200 volt DC scale, and the most I can push here is 40 on this particular power supply. Whoops, overshot 20. There's 20, looks good, and we'll go all the way to the max so I can take it up to, which is yes, I'm aware. The meter's warning me that I have set the voltage too high and doesn't seem to want to let go of it. So there's 40 volts, and I can actually push it to 41. So, you know, ohms, low ohms, and volts look okay, DC volts. You bring the voltage way back down. Bring it up to 1 volt. I've got the clamp at 10 milliamps. Got to move the lead for milliamps. Hopefully we're measuring 10 milliamps. The output is on. Not seeing any burden, which is interesting. So I should be measuring milliamps, volt ohms, milliamps. I would have expected to simply be measuring current through the shunt resistor in the meter. And so far that doesn't look to be the case. Of course, it's not drawing any current. I find it that interesting. I don't have an easy way to get a resistive load-in circuit here. So it looks like either the fuse is blown in the little meter, or maybe the current shunt has failed. Go ahead and turn the power supply voltage feeding to it off, and let's take a look at the fuse while we're here. I mean, I can't imagine that HRC fuses, well, you know, the tip is blown off of the positive lead. That tip has been melted off of there. We looked at that a little while ago. So it's quite possible, I guess, that something horrible has happened to this little meter. I can't imagine it's the HRC that's blown, but I'll know here in a second. It's a 3 amp fuse. The HRC fuse is open. Interesting. Let's dig out the spare. spare shows open as well. I don't believe that. They're both blown. Ah, well, it would help if I was using the right leads. Okay, that's on me. 0.13 ohms. She was holding on to the wrong leads before to measure it. No, this one is actually open. So that HRC fuse has been blown. So my assumption here is probably the little glass fuse here, which looks fine. Or does it? I don't know. I was, of course, making an assumption here that this fuse was really only for... Oh no, that fuse is fried as well. Well, both fuses have had the ass blown out of them. Well, that'd be a good reason for it not to measure current, but I'd say only the current input was... Obviously, I'm going to need to swap a fuse in 2 amp, 250 volt. Let me go find a fuse. Okay, I've replaced both of the fuses. We're hooked back up. I believe we're wired in correctly to push some current. I've got that 47 ohm load in series with the meter. And I'll start to bring the voltage up. And there we go. So 21 milliamps is good. 42 milliamps, should be 63, 84, and this is because that 50 ohm load isn't exactly 50 ohms. That's 100 milliamps, 150, so it's pretty close. It should be good to 2 amps. We're not going to achieve 2 amps. With this load, let's get up to half an amp. There's half an amp. Bring it up to 1 amp. Can't get to 1 amp. But anyhow, so we can see that it's actually measuring current. Let's bring the voltage down and go to the 20 milliamp range, and I'll bring the voltage up slowly. So that should be see, it's 20 milliamp range, so that's 1 milliamp, which I'm actually not capable of seeing here. Okay, there's 10 milliamps approximately. It's not correlating well. Let's see if I can drive it up towards 20 milliamps. Should be getting close to 30. So that's and 30 milliamps. Let's come to the 2 milliamp range. Oh, going the wrong way. 30 milliamps approximately. Let's bring it down to go to the, looks like get down below the 2 milliamp range. I'm going to have trouble driving current this small. So we're on the 2 milliamp range. By the time this kicks into where I can actually see a measurement on the voltage source itself, you know, that's 1/10 of a volt. and do about 47 ohms. Oops, that didn't work. 0.1 divide. Why is the... So that should be around 2.1 milliamps, and that's certainly not showing 2.1 milliamps. That's a tenth of a volt. No, it's 100 millivolts. Sorry, 0.1 divide. Clear. Got my old TI-30 out here. 0.1 volts divide 47 ohms. Should be 2.1 milliamps. That's certainly not 2.1 milliamps. I'm doing something wrong here. What am I doing wrong here? If I've forgotten Ohm's law, it's quite possible. Should be voltage divided by R. Let's get to a higher range. We're about 5 milliamps. Why do you keep doing that? Clear. 0.25 divide 47. Okay, so we're good there. So it should be around 5.3 milliamps, and it's a little low. But again, resistance is not accurate. I mean, I'm just poking at it here. You know, it's attempting to work on the current range. I don't know how accurate it really is. I guess I could put another current meter under the loop. And compare a nice high precision current meter to this much lower accuracy current meter. As always happens on the bench, the cables are starting to spread out everywhere. So let's see. That's 10 amp. Need to be down here for current. And let me break into the loop here. Find the best spot to do this. So I'm showing 800 microamps, 845, and this is on the 2 milliamp scale, so yep. 10.7 microamps, 10.7 microamps. 19.9, 19.9. So yeah, even down on the 200 microamp range, this guy's tracking well to my Rigol 305080, 48.8, 58.0. Yeah, it's tracking very well. 67.9, 77.1. Let's get up over 100, 106.3, 106 point. Yep. No, it's tracking very well. So on the lowest current range, there's 182 microamps on the Rigol and 182 microamps down here. So surprisingly, for a 30-year-old meter, 1.42 milliamps. Get up closer to 2. 1.95, 1.958, 1.957. Should overrange here. Both meters just jumped to the 20 milliamp range. 5.29, 5.3. Get it up near 10. There's 10.05, 10.07, pretty close. Not bad for just a little bitty portable meter. It's actually working pretty well. It looks like the fuses actually protect the meter from whatever they did that blew the tip off the red probe. Let's get it up close to the max count here. $19.94, $19.92. $25.5. Yeah, it looks like this little meter actually works pretty well, which is surprising. As old as it is. 45.78. Yep, 45.8. Yeah, I'm reasonably pleased. Let's get into the higher current side of things. So there's 61 milliamps, 61 milliamps, 94 milliamps, 94, 128.8, 129. I mean, we're not going to get to the 222.8, 223, 309, 309. Yeah, nice. Get up close to the clamp voltage here on the power supply. I'm actually pretty pleased with that. I guess it was worth doing the work to. So 773 milliamps, 773. We're that's the max current I'm going to be able to drive. 854 milliamps, 854 milliamps. Well, surprising. This little meter actually works pretty well for just a general little bench meter. It seems very usable. So I'm very pleased with that. So I guess there it is. Nice little Simpson model 467 true RMS digital multimeter with Digilog, the little analog display you've seen moving across the bottom. Apparently I can't do math anymore since I couldn't calculate the current correctly, but that's me. So I'll put this thing back in its little box and set it aside. It's got this little leather case. I think it's actually is leather, this little sewn case. Little pouch for the probes, which is actually a bit small. There's a charger hole, but there is no charger on this meter. The where the hole would be is filled here, so it wasn't designed for rechargeable batteries. This one doesn't have that option. But anyhow, hopefully this has been somewhat entertaining. Been a nice little look at this little meter. We'll talk soon. Bye. The more observant of you may have noticed I missed a step, which is just drilling and the reassembly of the little meter. And if I don't put it back together correctly now, it'll never happen. So let's put it back together correctly. Always miss something. Always miss something. All that juggling to get it into the little case. And maybe looking at it, you can observe what I forgot to do. You know, I sometimes think I'd forget my head if it wasn't attached. So this should be fun to get these to line up. That one goes there. That one goes there. Actually, not bad at all. It's the kind of thing where I could have not come back and actually finished the job, thinking I would get to it later. But we all know you never get to those jobs later. Okay, there's those two shields back in place. That little bit of added height should make it even funner to get back into its little box. It really does go inside of those little card guides. Getting close. Haven't jammed anything up. Yes, it's always something. Should by all rights be epoxying that other mount in place, but that's actually going to wait. You know, I'm not going to put a battery back in it. I don't want it to leak at some point in the future and destroy it. And I don't honestly see myself using it on the bench. I've got much nicer meters. Although the accuracy on it was really decent. You know, for what it is, decent little meter. Anyhow, it's now reassembled correctly. Talk soon. Bye.